हेलो लिसनर्स। आज हम अपनी इस करंट मैग्नेटिक इफेक्ट ऑफ करंट एंड मैग्नेटिज्म की इस यूनिट के अगले टॉपिक्स की तरफ बढ़ रहे हैं। टुडेज टॉपिक इज एम्पियर्स सर्किटल लॉ। दिस इज वेरी इंपॉर्टेंट लॉ and it is quite analogous to the Gauss law in electrostatics. So as Gauss law behave in electrostatics, the same Ampere circuital law behaves in magnetism. So according to this law, the line integral of magnetic field is actually directly proportional to the current. The line integral of magnetic field, that is B dot dl, integral B dot dl for a closed curve is equal to mu naught times to the net current I threading through the area bounded by the curve. That is B dot dl, integral B dot dl equals to mu naught I. This law have very vital applications regarding the calculation of magnetic field corresponding to different systems. Suppose there is a loop or a current carrying conductor in which the current I is flowing. So magnetic field around this in circular shape. So the line integral is B dot dl equals to mu naught I, means if the current is emerging out and the magnetic field is anti-clockwise. Now we are trying to prove this. Suppose B dot dl equals to cos 0. If we observe over in this diagram, we see that the magnetic field vector is quite in the same direction of elementary length. So B dot dl equals to B dl, and since the whole length is actually 2 pi r, if r is the radius of the loop, so B is times 2 pi r. On putting the value of magnetic field for a current carrying conductor, B equals to mu naught I by 2 pi r. So that is 2 pi r and 2 pi r will be cancelled out. So remaining part is just mu naught I. So this is the Ampere circuital law, and by this law we can derive for the expression for the magnetic field for a solenoid, for a current carrying loop, or for an infinite wire and different systems. So magnetic field at the center of a straight solenoid. This is our next application of the same law, that is Ampere circuital law. So suppose there is a solenoid having n number of turns per unit length in which current I is flowing. So the magnetic field B is we take then elementary rectangular area PQRS, a bound loop where A is the length and B is the breadth of this rectangle. So B, according to Ampere circuital law, integral B dot dl equals to mu naught I naught if I naught is the prime current. So B dot dl is actually contributed by the line integral of all the four sides, that is line integral corresponding to PQ, line integral corresponding to QR, line integral corresponding to RS, and as well as for SP. So the B dl cos 0 for PQ, because since the magnetic field, the length is in the direction of magnetic field, so here the theta is 0, but in case of SR and QR it is 90. So by using the same formula we get B integral dl equals to B dot A, that is mu naught I naught equals to mu naught NAI, that is mu naught NI, where n is number of turns per unit length, A is the length of the path, and I is the current passing through the lid of the solenoid. Same the magnetic field due to a toroidal. Toroidal is actually a circular solenoid which is also known as endless solenoid. So suppose there is a ring of and on which insulated copper wires are wrapped in this way. So this is called an endless solenoid or a toroidal. So suppose there is a current I flowing through it and we assume the elementary length dl, along which the magnetic field B is shown in the figure. Center O and the radius is R. So at the center the magnetic field is 0. So we have to calculate the magnetic field is outside point Q, at the toroidal P and inside. So B dot dl equals to mu naught I prime, that is B dot dl. B dot dl cos 0 because elementary length and magnetic field both are in same direction, so theta is 0 over here. B dot dl, B is outside the integral because it is a constant, and the whole dl is actually nothing but the circumference of this toroid, 2 pi r, and mu naught I naught equals to mu naught n 2 pi r times I. So net magnetic field is mu naught n I. So this magnetic field is quite similar to the magnetic field of a straight solenoid, so which means it doesn't depend that whether the solenoid is straight or a circular. The magnetic field is just depend on the current flowing through it and basically the number of turns of a solenoid. So the magnetic field exists only in the tubular area bounded by the coil, and it does not exist in the area inside or outside the toroid. That is, B is 0 at point O and point Q and non-zero at P. So this is now we are concluding this video for this law. In next video we are going to discuss one of very important topic, that is cyclotron, or basically the application of a moving charge in a magnetic field. So I hope you had gone through that you had gone through the previous videos. So most of the students are contacting that, sir, please update more and more videos. I'll try that before the regular classes we will upload most of the syllabus topic. Please like, comment, share and stay with touch. Thank you, learners.